Hello, welcome to another weekly live stream. Today we'll be doing something with the AI. I'm not exactly sure what exactly yet, but I kind of have an idea. But yeah, I'm trying to basically wrap this up over the next few weeks. We'll see how long it takes to do that. Without further ado, let's go ahead and get started. We're pretty much where we left off last time, unfortunately. Those are the patrons. They help keep the lights on. This week I was doing my taxes, so I didn't get a whole lot done, and work has been really busy. So I'm looking forward to getting some stuff done tonight and get on track for future completion and whatnot. Yeah, so what do we have to do? As you remember, last time we were working on the rest stuff, resting. And we could get the characters to sit down and stuff on a trigger. So that was kind of like just working out that the signal generators and the triggers were working. Which is like one of the last pieces to really start kind of wrapping it up. And then there's just like a ton of stuff to get done, little things and big things. And so I thought it would be a good time to like sort of figure out what the next things need to be. I need to make another page so that I'm not constantly shifting that. So like the existing exemplar mob types. So we'll say we had the butterflies, which are just purely random, essentially purely random wander. So those could probably be implemented today. The Gayfin are like the next most complicated. There's birds, but birds sit somewhere between butterflies and the other animals. So we'll go with the Gayfin because this is the most interesting behavior, right? The Gayfin, they had the so they've random wander. They had I hate that feature actually, to be honest. I'm not sure how to turn it off, but how do I, this way, yeah. Random wandering is like when you put a dash on the beginning and a dash on the end. That's like a textile or a markdown style markup, but in a word processor I find it annoying that. Anyway, so random wandering, we've got basic hunger eat mechanic, where it pecks at the ground. So there's a little bit of signal generation there. This one we could already handle. I'm going to go back through these and I'm going to add annotations to them about what still needs to be done to make these work. So basic hunger eat, lonely flock behavior, where if by themselves too long, they return to friends, which could be another player or the other Gayfin. The other thing is something fast enters view, they flee. Okay, then we had the dog, which again it had basic random wandering, didn't have a hunger eat mechanic. We probably could add a fatigue mechanic, but anyway, if some new actor enters view, will run to meet them. Meet them, not themselves. My monitor keeps going out. If you see my face go black and back, it's because for whatever reason my KVM switch or my monitor decides that I should stop looking at the screen for periods of time. So if some new actors enter views, we'll run to meet them, and so there's some memory involved there. What else? Oh, if pet will follow for some period of time. I think it may have another behavior, but these are the two. The human NPCs in the current version of the game don't do anything yet, so that's kind of what we've been working on. But now that I've got a new system in place that I think is, I mean, there's a lot of rough edges, but see, my screen keeps going out. There's a lot of rough edges, but without having like something solid to work from, it's really hard to like knock the rough edges off correctly. So I always go back to these archetypes because you know, the thing that flees from something fast and the thing that will like run to meet something, and then they cause this emergent behavior, is my standard how to test an AI system set of behaviors that I've been using way back since Neverwinter Nights, when some of us were crafting like some different AI systems on top of Neverwinter Nights. So a long time ago. So these are what we're shooting for, to rebuild these behaviors on the new AI, and most of it, like a lot of it's there. This could already happen. So down here I'm going to put a to-do list, sort of a high-level to-do list. Because one thing we don't have even yet is type-based config, brains, modes, etc. So like before we do anything, we have to have like at least the minimum, be able to even configure different behaviors. So like, yeah, the basic hunger eat where it pecks at the ground, we could already do that. Just like the player sat down, the peck animation's already there. We can already do that. Random wandering. We need avoidance probes. And then we could use the same steering behavior we already do. Could use existing wander steering behavior. Let's see. Lonely flock. So this requires that it go to a specific place. So we need a dumber pathfinding. Avoidance probes. That might be it. But there's some implications here. The avoidance probes requires well, we'll break down avoidance probes down in the to-do list. The dumber pathfinding means like currently, you know, when the human does pathfinding, it actually does intelligence where it figures out it can walk around things and stuff like that. But we need a pathfinding. Let me go ahead and run the tool in the background so we can talk a little bit about why. But I want to have a dumber pathfinding that still uses A star, but that the heuristic is so heavily weighted that the animal won't actually like route around. So the animal couldn't necessarily figure out its way through a maze, for example. So let's talk about this. Plus, it's just good to have graphics. Right. I turned off the resting behavior for now because it was annoying to have my character constantly walking back over to sit down at the nearest chair. So like right now, if I was to go to the brain and I would say, you know, make a dagger, it's going to plot a yeah, so it's going to plot a walk path, and it's going to know it needs to like step up the steps, it needs to open the door. Right now it's going to this particular chest to see if it's got anything that it needs. Its hammer's not there, so it's going to calculate a path, like a way longer path. So this is like the smartest sort of omniscient version of pathfinding, and it did a let me go ahead and cancel. You know, so it did a lot of, if we were to go to the navigate and we would see how this would navigate manually, like we could see it's, you know, trying all of these different paths That was 600 iterations that it did it. So it found all those paths, and then step a little more, and it'll find more, and it'll find out they can go through the door, and so on and so forth, and then create a path. And so it tried all these things in case there was a wall here. It needed to go around the wall. But for something like a Geffen, which are essentially dumb, we wanted to try the straightest path possible, and then if it can't figure it out within like a certain number of steps, just give up. And the reason is one of the things we got into. Let me stop controlling myself so that I can not control. Stop following. One of the things we had problems with before was with the contact avoidance. Like, how do you know the difference between a step I'm supposed to steer around between a step I'm supposed to step up? These are obvious. Like, I could step up, and most of the Mythruna mobs should be able to step up this. But like coming up this full meter block, it requires like a special action by the player to decide that they're good, or by the mob to decide they're going to go up there. But for a Geffen, like, it would just steer away from this because they're shorter, and so but a Geffen could fly up there if they decided they needed to be up there. So we still have to do pathfinding because we need to know, like, if the Geffen was trying to get from here to here, its straightest path might be to just hop up onto this thing because it can fly a little bit. But that's a special action on its part. It's not just walk straight. And so, like, the behavior now for all of the mobs in Mythruna the game is that they just kind of steer in the direction and they hope for the best. And the sort of contact avoidance sort of steers them around walls and stuff. But that means they can't walk up steps. They can fall down steps, though. And so, like, the animals tend to get caught in pits and things. And they don't do the Minecraft thing of just, when I hit a wall, jump. When I hit a wall, jump. When I hit a wall, jump, and then hope for the best. Yeah, hide-aware pathfinding. This is already true, right? Like the when the human mob does pathfinding, it knows, like, if I was to place her over here, like, just to give an example, so like she could technically jump up there if she wanted to, and so there's the pathfinding knows this, and right now there's just nothing stubbed in to do the jump, but it knows that it should take a jump action. It just never creates one right now. So the current pathfinding, so a jump would be really expensive, and it would still, probably in this case, it still might walk around to the stairs depending on how expensive we made a jump. That's already built into the pathfinding. But for something like a Geffen, they're not very smart. If they hit a wall, they're just as likely to fly up. They don't know that they can smartly walk around here, right? So we want a version of the pathfinding that basically tries to make a straight shot. And the reason we can't just use regular steering for that is because as soon as it hit this lip, it would try to turn away and go somewhere else. And so we can't. This is the problem in the current Mythruna, is that Geffen and any of the creatures, that dog or anybody, they can't run up ramps, and they can't hop up blocks. And so that's like a big problem. And by using pathfinding, at least they'll know sort of the way, and they can route around some simple things if we give them a little squish. And I think the way to do that, so A*, the algorithm that does this pathfinding, it has what's called a heuristic, which basically decides the suitability of a path. Let me go back to the navigate, and we will try to go to the front door, which is start. Hey Peter, how's it going? Peter and Fizzy Arthur. And so if I do these like one at a time, we can see, so her trying to path to the front door is, we're doing all these things, but we're checking around in all directions. We just prefer a certain direction. And then eventually, it'll eke around here and find its way up the door. A Geffen is not going to be as smart as a person, and so what happens is there's a heuristic that's based on like the suitability of each path so far. So we would tend to try the paths that are more suitable than others. And the heuristic that's usually used is a distance heuristic. So the closer a particular pending path is to the destination, you weight that at, you give it a weight, like a WEIGHT weight, higher, so it's more suitable, right? But usually scale it in some way, because if you did it super high, this is exactly what I'm talking about. If you did it super high, she's only going to try the paths that get her straight there, and she's going to be reluctant to try the other ones. And so there's a balance between trying to find good paths. And so for the Geffen, I think what happens is that we just pump that distance heuristic up so high that it never really tries alternative routes that are very far beyond. And then we clamp it so that it would never try any path that's longer than basically a straight path. So it might like route around like posts and things, but for the most part it's going to try a straight shot. And we would never have it try to go like the same kind of distances that we have the human player go. And it's never going to hit any kind of walk graph or any of that stuff. Right now this pathfinding is omniscient. It assumes that the mob knows every inch of this place and could always calculate the absolute best path. And even for regular mobs that's not going to be true. There's going to be some amount of a similar sort of rejection of paths that there's no way they would know kind of thing that I'll have to figure out at some point. But today omniscient at least works. But so for the Geffen, yeah, I'm just going to heavily weight that nav path so that it tries to only go straight to it and tries very few alternate paths. And basically, I think even the current approach, I think I might be able to weight the heuristic in such a way so that paths that are too far outside of that straight line are not just negatively weighted, but negatively weighted so far that they're considered impossible, and they'll never sort unless we really run out of things. And so, but then like there's a certain number of hops you expect to happen to get there, and if the path ever exceeds that hop, then we reject those too. So there may be some tweaking to the algorithm I have to do to allow like path rejection, which isn't supported right now, but you can effectively reject a path by setting its heuristic up so high. And so then technically you could start seeing if you try a path with like an infinite heuristic, then we could just say we're done, but that we failed kind of thing. I think there's a way to do it with the existing system, and if not, there's something to get very, very close, and then we can enhance the system later. Because today I'm all about getting it done. This next couple weeks, I'm all about getting it done. I'd like to put out a June release with better AI in it, with maybe actual creatures that like do more than just want random wander. So I'm trying to wrap this up over the next few weeks so we can get it in the real game and start making real behaviors and things. Maybe populating some dungeons with some things. I don't know. So that's the deal. Is the reason that I want to add pathfinding to Geffen is just so they know when they're supposed to jump up versus when they're supposed to walk around something. The other thing is so there's that, and the avoidance probes is important for even regular players need. So these also need avoidance probes, like the dog needs avoidance probes. Because what that will do is not only allow, so like if this player, we already hit this when we watch this mob pathfind, because sometimes it gets stuck on corners. Whereas if it had projected a little bit of, a little query shape ahead of it that says, oh, I'm about to hit a wall, it could turn right, and so it could kind of slip past these things without getting its individual feet and stuff hung up on the corners. And the same holds true for right now, let me show the queries so you can see. So like there's these nav queries that are done that like query the physics space, and like blue means that it's below them, and green is like right on the line where they're the ground, and then this is like things they could step up onto. These are things that they would have to jump up onto, that kind of thing, and then up here is stuff that would always block them. We need a similar thing, and this is like actually like 8 different queries right lumped on top of each other for that particular spot. But we want something similar while they were walking, so that if they happen to walk across a small gap in the floor, or they needed, say there was a another block over here and there's an empty block here, and they were trying to walk from here to here, they would know that they need to like sort of navigate around that pit to not fall in the pit. So it's going to be a query shape kind of like this. So a little more complicated than our old sphere that was just kind of at waist height. AI for animals, mobs, yep. And so then, so I have like so I need to work that out. The contact avoidance is like the big missing piece right now, because we need to, when they're standing still or when they're walking slow, their query shape needs to be kind of right on them, and as they speed up, it needs to move ahead. The other thing I want to do is the elastic pathfinding that we had before. In the old prototypes, when the mob was following a path, it, rather than targeting like the immediate path in front of them and walking this in some rigid zigzag, it would send a probe kind of ahead. So it would project itself ahead on this path and target that spot, so that by the time it was stepping here, it's probably targeting this over here, which kind of smooths all this out. And that kind of also means that it needs to project its query shape forward. So there's this interaction between the walking of waypoints and the probes, and that also has to happen for the same reason for stepping up. Like if the mob was walking this path, the default would be that its query shape would see this and it thinks it should turn away because it doesn't have the action to step up, so it assumes it's going around. So there needs to be some built into the pathfinding, and this is, oh, by the way, as we approach this step, pull your probe in or ignore results that are like a step up, because we know we're going to be stepping up, kind of thing. Or we set the action up so that it doesn't have a probe in effect while it's stepping up, and then the probe goes into effect again. Something to that effect, but the bottom line is that the walking of waypoints and the probe need to interact in some way so that there's some of this elasticity. So anyway, so that's kind of like, to me, this is like one of the biggest missing pieces right now that we get into it. If something fast enters view, so for this we need view probes or view queries. That's that frustum that we had before that I showed that already the current AI has. So we need view queries to signal generators. And we need I think the existing flea behavior could use existing flea steering. Especially for a Gaphin. For those who may not know what a Gaphin is, if you're new to the channel, if you're new to the game, the Gaphin are these little chicken, geese, duck things. Penguin, chicken, geese, duck. They kind of fill the role of a lot of different sort of domestic fowl. So they have like a little personality all their own. But anyway, that's what the Gaphin are, and so they're my chickens basically. And so their flea behavior could just be dumb. Right now, it's like just run in a certain direction, and so if they end up in a pit or whatever, that's fine. I may change the steering behavior. It may need pathfinding. So to also use pathfinding, because like I said before, because the way that the current stuff builds out, the low-level steering doesn't know to step up on things. That's part of the sort of the nav path, and so unless it plots that it needs to run, so if the plot's just going to run in this direction, it'll get stuck. But even a Gaphin would like fly up these places, so it could be that we still want to plot. If something spooked it over here, it's going to try to fly exactly in the opposite direction, and so perhaps we do that. It could be dumber than that. Like we could set it in sort of fly mode, which could have it sort of not. It'll still walk, but kind of fly. I don't know. Anyway, I kind of think that in the short term we'll just do the same thing we would do for trying to do dumber pathfinding. So the dog has a lot of avoidance probes. Yeah, I could use existing wander steering behavior. And it's, again, if we had better avoidance probes that could keep them from falling into pits, that would be better. Like right now, they can fall into pits because they don't detect when they're walking off an edge. So this requires view queries, signal generators. Dumber pathfinding, maybe slightly smarter than Gafen, and similar. So it also requires avoidance probes. So yeah, like our existing behaviors don't do much, and so they're not too hard to finish. So this is this custom signal. No big deal. And then dumber pathfinding, maybe slightly smarter than Gafen. There's the idea of a follower pathfinding is interesting to me too, where if you have a pet and the pet is supposed to follow you, or if you have a like an NPC you've hired and the NPC is supposed to follow you, that they might mimic your path, and so there's some where they have the ability to observe you. They might look at and remember how you did something, and then they may try to emulate that path. So there could be something, smarter here in the future. So what we get out of this, first of all, we need to be able to type-based configure brains. Want to think about how it would work in the real game instead of just cramming something in. I probably will just cram something into the prototype, but I also want to think about how it would work in the real game, because we'd prefer some kind of Groovy based config eventually. Okay, so then we need avoidance probes. Avoidance probes need leading interaction with path following. We need, how do I outdent? Like this. What else? View queries. Oh, for avoidance probes we also need better collision shape, like in the prototype. Just a sphere. What else we need? We need view queries. Can steal code directly from current Mythruna a bit. Workout. No, that's a separate item. So we need I wish I knew the hotkeys a little bit better. Dumber pathfinding, sliding scale as to how far out of a straight path it can navigate. So the other thing is, actually we can make that a separate item. So the other thing is priority of some kind for dealing with flee, where we don't want to wait long for a path solution. So right now, when we do a nav, we like iterate only like 10 times per frame or something. There's a built-in, like, you can set it, but for something like this Gayfin wants to run away, we don't want to spend too many frames calculating that flee. It should like flee right away, and so we may do a dumbed down. So in the dumbed down pathfinding, it could be that we always want to do, for a certain priority type of pathfinding, we always want to just run all of the iterations we're ever going to run right away to get an instant response at the expense of CPU. What else did we leave out of this? Custom signal handlers, that's fine. Yeah, so this is, let's see, what else do we need? We need so basic hunger style, basic hunger loneliness style signal generators. This can already be done though. What else am I missing to get the same behavior? That could be it, actually, to be honest. Oh, the walk waypoints with springs being interaction with avoidance probes to turn on off in certain cases. Project ahead on path to have a steering target. Adjust projection based on speed. These, I'm just writing the implementation notes to think if I'm missing anything else. I think that's it. So if I'm pretty sure if we had all of these things, and of course all implemented in Java, all of that ported to actual Java non-prototype code. Like, it doesn't all have to be Java, but most of it's like the hard classes, like the concrete classes, are going to be Java code. So I think that's it, and like we could jam on this a little bit today. We would have to do a minimum amount just to do anything else. We could mess with view queries a little bit. What do we got? We got an hour and a half left. We could mess with the avoidance probes. The thing is, like, from experience on these live streams, this gets a little tedious. I don't know if it makes good content, but we could mess with that. It's a steering, usually a steering influence, but it doesn't have to be. I guess it does, though, because we're just trying to sort of not steer in dumb ways, and so we affect the steering. For the prototype, we'll also want some kind of debug view. Yeah, like avoidance probes. We could mess with dumber pathfinding. I'm trying to think how we would visualize that. Well, we could add the jump action, for one thing. right now, like, so the other thing is I haven't implemented is the actual step up animation, and so when, Mythruna girl, she just teleports up because I don't have an animation, a force, I don't have a set of force animations or that I've found that works well on the steps. I've found some that work okay on a single step, but then when running up these steps, she gets kind of like a bit of a momentum, and by the time she gets up at the top, she like jumps half a meter. So I need to work out sort of the balance of those. What I'd really like is just animate stepping up and have the animation take care of it, but that turns out to be trickier than you would think. Yeah, because as it's stepping up, it's like, where is the actual position of the object? Actually, it might work. Anyway, whatever. It also doesn't work very well for ramps, and ramps are treated similarly in some ways. So what do we want to work on? Maybe we'll hack something in for this so that we can do the rest. So then, yeah. So if we have basic, I'm trying to think, what do we have to do to have dumber pathfinding? We have to have. So when we create this agent driver, one of the things we add in is the nav function, which is like how it creates its actions, which would be custom for different kinds of mobs. Humans will create like step up and open door actions and things like that, and a Gayfin would not. It would jump and fly and no opening doors or any of that stuff. Nav grid is universal, and I'm actually probably gonna move it into the nav function again, and then. Yeah, we already have a separate bipedal config. Yeah, the other thing is like for dogs, we need quadruped movement mode. This is tricky. As you see, like if we run, I've shown this before, I think. If I create the dog. There we go. And which one is the doggy? Yes, these have gotten too big. He's going to be the highest one. So if I control the dog, like he can run around and he can walk up these but like when he's walking up a slope, it looks really strange. Oh yeah, his movement mode's all messed up, which is why he's not walking as fast as he could. But like if I stop here and we center on him, you see, like the movement mode's not right. We either need to have like an animation of walking up the hill, or I at least need to tip him in such a way that all 4 feet touch the ground. In the short term, this could work, but on long term, quadrupeds are going to need a special kind of movement. The other thing is their query shapes and everything are weird. Currently, I think the way we'd implement it is just have the query shape around the shoulders, which means they may pathfind themselves into places they can't get out of. So that should be interesting. But he's doing a really good job of station keeping. One of the problems with especially the dogs, but all of the characters would slowly slide down the hill, so at least the station keeping code is working okay. So I think, yeah, the dogs have their own challenge. This is actually going to be the most brain work of all of these. All of this stuff is straightforward, but just work. But let's see what we can do for creating. We've got this place here where we're already kind of hacking in 2 bipeds and a dog suit. You're not wrong. The funny thing is, I have thought about that. The idea being, what was that game where it's a bunch of the like humanoid rabbits, and they've implemented an entire procedural IK animation, right? IK based animation. Overgrowth, I think, is what it something like that. It's like you have these like humanoid rabbits. You can like run around the world and but he's like done procedural animation and IK for all the things. And I sort of covet that idea. And I've thought many times that a dog could be done if you had all the IK stuff set up as two bipeds in a dog suit, as you say. I think it would not look exactly right, especially running. But yeah. So anyway, so let's right now we could hack in some. If it's this type, do this. If it's this type, do that. Because we already have a little bit of that code here. Yeah, overgrowth. Yeah. It was fun to watch his social media posts about that. Okay, so here we would want to pass a different nav function. Where did we get the nav function? I bet it was... Where do we get it? Okay, nav function, yeah, was passed in. That part I know. Oh, we create it right here. Aha! Okay, so if we change this, which I think is defined in another... that's defined in the setup nav. Yeah, reload. Oh. I want to search on this. Yeah. Does mobs disappear after a short time or not? Yes and no. There are two types of mobs, even now in Mythruna. There's the random encounters, which are for, if you think about the what do they call it? The food chain, right? You've got the prey at the top, or the prey at the bottom, and the predators all the way up the top. Generally, the lowest level type of creatures in Mythruna will be random encounters, like the butterflies, the birds, probably maybe even like rabbits. They will rabbits especially will generate because there's a warren or whatever nearby, but it tends to be anything above that. They become real persistent entities that actually have a life in the world. That's the idea anyway. So that so the dog in the town, the NPCs in the town, they're persistent. But as you wander around right now, the butterflies spawn, the birds spawn. If you move out of that area, they despawn, and when you come back, it could be new butterflies, new birds. They're not kept around. So they're randomly generated, randomly despawn, or not randomly despawn. They're despawned when they go out of view, and they never exist again in that particular entity. So I think I want to create a second nav function. We're going to call this first one create by smart nav function. Smart. This is how these two files communicate. And so we'll change the name here, and we'll do that, and everything will break. And then we will do the same thing over here. Replace. And everything should fix itself again. And we can check by having fade. Oh, now he's sideways. He's slowly slipping down. So the station keeping's not perfect. Brain work. So she'll plot a path to her job, and we can verify that it didn't break anything already working. Okay, so she's going to do her thing. Oh, cool. She's going to go up the ramps. Yeah, she's a teleport up. She doesn't know that she can, like, she can't animate up the thing, so she teleports up. Boink, 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 boink. Really got to fix that. Okay, anyway. So, I mean, before she gets behind the door, I'm going to cancel her pathfinding, because as soon as she gets behind the door, I can't manually control her back out here, because I can't manually control opening and closing the door. The limitation of the prototype at the moment. Okay, so that's working. We didn't break it. So we can... I guess they have different probe shapes already. So let's make a dumb bipedal nav function. Dumb and dumber. Okay, so let's find this one, and we're going to duplicate it and then make it dumberer. Dumb physics nav function. Okay, so this one, there is never going to be an object action. They don't know how to use doors. I think I have stubbed out the... Yeah, I don't think we do jumps. What do I do for a jump up? I think... Yeah, we don't allow this yet. But for a dumb one, I think we will temporarily support it. Jump. Make sure jump up. Yep. Okay. So look. Okay, let's see if that compiles. Seems to have. So yeah, for jumping, I'm basically just using the step up action for now. We will call it a jump up though. Now I'm gonna leave it the same, so I don't know the jump up would be rendered. These are for like debug views. If accurate Y, which I think we're always accurate Y now. Yep. So one thing my editor does that I like is it lets me set it up so that it will let me Control Z back through my cursor movements too. This gets me in trouble in IntelliJ. I don't know if IntelliJ can be configured this way or not. I've never really looked into it, but I tend to be hands-off on the config over there. But one thing I can do here is like I can decide, oh, I'm going to search for where this is defined, and oh, okay, it's defined there. And then when I'm done, I can hit Control Z and go back to where I was. And in IntelliJ, that's actually undo it. It'll take me back to where I was, but that's because it'll undo the last keystrokes I did there, which is not exactly what I wanted. All right, so the dumb one should allow stepping up to big places. That'll be one way we see that it's different. And did I just change the real one? I did change the real one. The original. So, yeah, so I copied it and then so the first one is the dumb one and the second one is the non-dumb one. That's fine. Yeah. Okay, and so it should not be able to go through doors, which means to get anywhere it would have to go through windows. I don't know if it's short enough to go through a window. Okay, and then all that's good. Let me make sure this isn't... I'm trying to see where all physics nav functions used. Yeah, so we manually create it in these nav dialogues. I was hoping I could use the nav dialogue. When I click here and I do navigation, navigate, that's using this nav dialogue. And that's useful because I can see all the different steps I'm taking. And I'd really like to be able to test these with that. So I think I need to make sure that the nav dialog can use the custom function. And so we will find where we show agent, query shape, collection targets. We want, let's make a nav function factory. Private. Ooh, it's going to take a lot of parameters though. So make it a supplier, and we'll build the parameters into the thing. Supplier nav function. Am I importing this? Yep. Nav function factory. And so we show the agent body, query shape, targets, and nav function factory. This dot nav function factory equals nav function factory. I don't know if I need anything more than that right now. And so then when I actually do this instead, I want to do this nav function equals nav function factory factory get. But where did it get fizz, nav grid, query shape, and filter? Wasn't in here. Oh, all these places. Wait. Fizz is the physics system, I believe. Yep. Where did it come from? Not there. Oh, we must set it externally. No, where does it get set? Yeah, right here. Okay, so that's fine. We'll have embedded that into our factory. Nav grid we could have embedded into the factory. Is nav grid used for anything else here? Okay, let's see. Nav dialog, nav grid. We set it. We don't even set it anywhere. Reset nav grid. So we used it here to get a key. It's the only thing we use it for. Okay. So we probably don't need it actually. Query shape. similarly could be embedded, except for I think we use it to render. I think. Nope. We just have it, so we don't technically need that either. So I'm just looking at it, whatever we use to create the yeah, so we used to pass it to the nav function, and then we don't have to do that anymore because we're just going to be supplying a nav function. And the filter could also be passed as part of the nav function. So we could just replace all that with the nav function factory. Cool. That's actually better. But let me see all the different places nav function is set. I think it's only here. Nav function set there. Yep. Okay. And so somewhere we call show, and that is going to have to be navigate show, and in here context nav function factory. And so then that's fine, we just broke it. In the body context, this would be so much easier in real classes because I could just do it like you would normally do it. Nav function factory. Okay, and then wherever we set an agent driver, this is where we can set the nav function factory. Yeah. And so it's not really a factory in the classic sense because we're going to just say nav function factory equals and we're just going to have return that nav function that we just created. I think that works. Oh, nope, broke something. No such property nav function factory for class body context. What you say? Nav function factory. Let me just make sure that's true. Sometimes we get in this recompile class mess. It almost always is true, but so when we start up, does it fail? Well, it wouldn't fail until we go to create a human female. Create mob. Yep. No such property nav function factory. Possible solution nav function factory. What did I do? NAV function factory. NAV. Oh, lowercase f. To my eyes, I need glasses, but to my eyes, lowercase f and uppercase f look almost identical in this font. So, that got me. So let me make sure that she can still. Oh no, big problems. Null pointer cannot invoke method gets on null object. Let me delete her and recreate. And then try navigate again. No. Get on null object. Nav function factory should not be null. We're setting it right there. So over here, let's log it. Log info nav function factory context, not context nav function factory. There's a certain aspect to this that's faster in regular Java. Okay, so let's try again. Navigate, and we should have gotten some debug information. Nav function factory. We have a function factory. Okay. Can I invoke get on null object in 1488? Oh, wrong key. Oh, I think we need to set it right away. Otherwise, so one of these things is resetting the nav, and that's where it's coming up. Okay, let's try again. Navigate. Ah, okay. So yes, let's see. Will she try to go to the start step? Yeah. Okay, so she's doing her regular smart pathfinding, and she should actually end up going through the door. Yep, she figured out the way through the door, and then we should be able to say execute, and she should walk through the door. It's a little disappointing that the navigate doesn't actually draw the path, but that's okay. She opens the door, goes through the door, walks over to the thing. Okay, so we're all good there. We could have her navigate back to the front door to get her outside of here. Front door being the front door of the house. Yeah, clear, front door. Start. Step X. Step X. Yeah, I don't know why it keeps putting these pendings in the walls. It has something to do with the door action. So anyway, let's move this over here so we can see. Yes, she should get all the way to the front door. Yeah, so she nav all of this stuff, and so we can get her to start walking and get her back outside before we cancel it. She open the door, she leaves, and those doors open too far. Okay, so when she gets out back to the middle area, let's cancel. Cancel. There we go. Center on her. All right. So that's, we've got it wired up to be able to have different nav functions. And so up here, we will change this to say context. Okay, first of all, this we can move up here. The query filter is going to be the same for everybody. Basically, let everything in but myself, so you don't hit yourself in the queries. And then so we want context nav function equal to, what will it make? I'm just going to copy this for a second. Nav function. Yeah, actually, let's make a nav function on the context. Am I still? Yeah. That's fine. Hey, so I could have done it different, but okay. So nav function factory, context nav function. We don't need this anymore. Oh no, that's we don't need this anymore. We'll move this up into here and into here. Make this context.nav function. I guess we have to move it out because everything needs a nav grid. I have to really sort out. Nav grid basically decides how to split the world up into cells, because we Fade, or the Mythruna girl, is considerably smaller than a full meter block, right? So she uses a nav grid that's like a quarter of a block or something like that, so that we get reasonable resolution and allow her to walk between things that she can walk between. So this one's going to be the dumb one. And all of that's good. Let's see if it compiles. It did. Let's see if she can still navigate through a door. First, let's see if she can navigate through the door using the brain. Apparently she can. So she still should open the door, close it, and so on and so forth. Sure enough. Okay. And so we ought to be able to get her to go sleep too, which she'll navigate all the way back to her room. Takes her a while. This is why we make it last multiple frames. This is where a town nav graph would help considerably. Okay, so then we'll cancel. So that she just sits there. Okay, now we ought to be able, let's just double check that navigate would navigate all the way back through the door. We want to see it. Oh, we're not seeing our pending. Uh-oh. That's not a good sign. Let's clear, start, step X. Oh, okay, we are. Okay. Oh yeah, I'm still controlling. Oh, I'm not controlling, I'm still following, yeah. Navigate. Step X. Oh, yeah. It reset when I reshowed. It doesn't work like the brain. The brain remembers. So it's clear, start, step, step, step. Okay, she found her way again. You can actually like look at this and see that she did, but yeah, there's something weird going on. It doesn't resize itself properly, and in this case we just found out that it will, oh, it's not even, the brain will, anyway, the brain dialog works better. Navigate is the old stuff that we started with. I haven't really kept it up. Okay, so now let's make a Gayfin, and yeah, I gotta remember how to do that for a second. So Gayfin, create the mob, do like this. Okay, so the Gayfin should not be able to go through doors. So if I go here and I navigate with the Gayfin, yeah, clear, start. So he should not be able to make it through the door. So he's going to try the whole level, right? He's going to see if there's some sneaky way he can get in through a back door, which is not realistic, right? So this is the one thing we want to fix. We want to change the Gayfin's default heuristic. Yeah, so see, it's even checking behind this building over here, just in case there might have been a little door out there that led to that. This is what I'm talking about, omniscient pathfinding. It knows the whole map and it's memorized the whole map, and that's not very realistic. Like, if you took this NPC to a dungeon, he's not going to know how to navigate around every specific inch of that dungeon. It's going to be just, he's going to be just as lost as you are, and so there needs to be some dumber pathfinding that's smart. Anyway, so the Gayfin is still being semi-smart. We want it to be like 100% dumb. And so that's not a nav function problem. That is a, I mean, it kind of is. What we want is the default. What happens is, let me see if I can run through the logic here. So what happens is the pathfinder, I'm not sure we can adjust it here, to be honest. The pathfinder will call this method, but given it a position and given it a position, give me a bunch of other positions that I might be able to navigate to as actions, right? It's like, it's not just about I can go to this position, it's how can I go to that position? Is it a step up position? Is it a climb ladder action? Is it a walk through a door action? And so then, the pathfinder gets a list of these and then decides based on the current cost which one it will pursue next to continue on until it gets to where it's going. And I think it's the pathfinder code itself that sets the heuristic. We don't do that here. And that's unfortunate. That maybe should be built into here. I really want to change this to be a so right now it's a nav function is a function that takes a position. Ignore this action factory for a second. Takes a position and returns a bunch of actions. I kind of want it to be takes a path, returns new paths. And a path already has an action in it anyway, because then we could set the heuristic in this function. But as it is, everywhere we have a pathfinder, everywhere we create a pathfinder, we would have to adjust that heuristic. Well, we can test it at least. So where's my show method? I think body we still need. Let me see where I create the pathfinder. I want to work out in principle whether this can work at all. I think that Pathfinder can have its heuristic function reset now. I just have to remember where to go. There we go. Alright, so it has a heuristic func that it can have reset. And so we shall. Yeah, for testing, we have a target location. Yeah, so we used to have, yeah, so if true, I'm just going to put this so it's easy to take out again. Pathfinder heuristic func equals takes a path, returns a double. And what we want is path end location distance to target loc, and then I think the regular Pathfinder returns. What does the regular Pathfinder do? What's the default heuristic? Or is it? Oh, it's going to be in the nav targets. Yeah. Path. Just returns the distance. But we can multiply distance. I gotta go back over to here. So if we return like distance times distance, distance squared, which we could have gotten originally. Okay, so Now everybody will be doing dumb pathfinding, but what we should see with the bird specifically is that it tries for the door. It tries to go straight to the anvil, but then we'll bunch up and try every little bit around here before ever branching out behind it. That's kind of what we want, and then we want to limit how far it can search. Because if it could fit through the window, it would try to jump through the window, that kind of thing. Navigate. So we'll set it to go to the anvil, and we'll show pending, and we'll step. So see, it's trying to head straight there, and then it will like bunch up. And so at some point, we could decide, no, you've run out of attempts, right? And so, like, you should have been able to make it straight there by now. You couldn't figure out how it wasn't as simple as just going around a tree or something, and so you're done. And it should still not go through the door. Yeah, so it's slowly working its way. But this is what happens when you set the heuristic really strong, right? The distance heuristic really strong. It's going to try to go straight there. And that's kind of what we wanted in this case. We wanted to try for a straight shot, or as close to a straight shot as possible, and then give up. So similarly, if we clear this and we had to try to go to the front door, we'll see it try to go up the steps at least. So start, step. It should head straight there. Let me move over so we can see better. Step. So basically as straight there as it can get. Yeah, so it heads straight to the door and it makes it, right? But it knows to, I wonder if it can actually do it. Yeah, so it'll go straight over to that door. Oh, look at him go. He's walking fast. Boink. Uh-oh. Did he fail? He failed. Why didn't he jump up? Uh-oh. Oh yeah, there's a yeah, she should have jumped up. Okay, something's going wrong there, but the pathfinding in essence works. And the dumb mode without limits works. So we need to be able to parameterize this across the board. I think that right now I built the heuristic into the Pathfinder, but it really should be sort of personality based. Right? Different types of mob will use a different heuristic function. So this shouldn't be a property of the Pathfinder. Nav function, it makes sense. So let me add to my to-do list, because I don't think I'm going to do this on the... Well, we could. So to-do list. So like we've kind of skipped this. We hacked something in for now. But modify nav function to be position path instead of position action. And the path has the action in it already. But by making this then move heuristic calculation to the nav function. It's like right now, well, I mean, is it situational? So if even a smart player, like a smart mob, like a human, if they are trying to flee, they would probably weight WEIGHT, the heuristic, to nav function. But am I thinking too much of a special case? Still need some, so I'm going to say still need some ability to override heuristic. Yeah. Situationally. I just feel like there's cases where an NPC has plenty of time to calculate the best way to go get lunch. But if the wolf just barged through the door, it's going to try to pathfind away as quick as possible and not necessarily make good choices. And so in that case, it could be a more panicky heuristic where it's like more like the one right now, where it tries to run straight away. The other thing is nice ability. Hey, how's it going? Long time no see. Ability to reject paths. That are too far outside of the ideal path, or for any reason. Right now, we can accept paths, but we can't reject them. Like, we can say, yeah, this is the solution, but we can't say, no, don't even proceed down this path. The only way we could do that is to give it a heuristic so low, negative infinity or whatever. But it'd be really nice if we just never considered it. And so then what that means is, in this case where we had the let me take the Gafen back over here. So like when we had him trying to get to the anvil, navigate. Oh, I want to center first. Where we had him trying to navigate to the anvil, start, you know, and he bunched up right near the wall. Instead of allowing these paths and still trying them, once they fall too far outside of the straight line, we could just reject them outright, in which they would never show up as pending paths. So we'd only allow him to vary, to steer outside of the ideal path a little bit before we start rejecting them. Whereas right now, if we step long enough, he's still going to try to navigate the whole level, right? If we do enough iterations, you know, and there was a way in, he would eventually find it. It's just he's taking the really slow route because he first tried the best path. And we don't want him to try any of these. And so the ability to reject, to outright reject paths. And that's actually, if this was, yeah, I'm running the wrong screen. If the function was, give me a position and I return a bunch of paths, it could be smart and just like not return these paths. And so that could be something built into the nav function that doesn't even bother to create those paths, which is actually the ideal case, right? Before we even created the path, just don't even bother. Is there not situationally? I thought there was a word situationally. I mean, I believe it's a word. But then like I said, there are times when we might want to switch that out. And is that up to the... See, that would be activity specific, a flee activity. And that activity could wrap the existing nav function. Yeah, I mean, it would work, right? It could wrap the existing nav function to basically, call the original nav function and then reject paths or set their heuristic different. So yeah, I mean, if I did this, it allows a bunch of different things to be done. And I could remove heuristic calculation from the Pathfinder. Pathfinder starts to become dumb, and it becomes like really just a graph search tool, which is alright too. We could work on this. It's Java code, so we'll be like stopping and starting this a lot. But we've got like half hour left, and this is something I've wanted to do for a while. So yeah, maybe let's do it. So built into the nav function becomes the intelligence of the mob. And then we can override that. I like it. Okay. So right now we have nav targets, which implements nav function. Oh, it implements target condition. Oh yeah, nav function is separate. Yeah, totally. Yeah, nav function is what defines, yeah, it's a by function. Takes a position in an object action factory. So yeah, I eventually added that because I ignored this when we were talking about it before. But if we look at the not this file, this one. When I was showing you the when I was showing you this method, right? It takes a position, and I said ignore this parameter for now. That object action factory was something I added because the pathfinding already knows when it bumps into objects, and sometimes you want to do special actions when you bump into those objects. The common example right now is when you bump into a door. Instead of just saying, "Oh, I can't go through that door because it's blocking me," you have this chance of saying, "Oh no, we can create a action that says open the door and step through the door and then proceed from there," kind of thing. And the other thing is when you have, like, you're trying to navigate to a particular object, and right now we put like the position of the center of the object, which if the object is particularly big, if you're coming at it from the corner, then you're kind of really far from the center versus the side where you're really close to the center. And so a lot of times mobs would get stuck on the corner. They weren't actually close enough to trigger the distance check, but they were actually bumping into the object. And so this is another case where if we detect, hey, the object you're trying to reach is if the object you're trying to reach is one of these objects, then if the object you're trying to reach is one of the objects we bump, then you can actually create a touch action, which then your acceptance function can say, oh yes, if you touch the object that I'm trying to get to, even if you're not close enough, we'll consider that the valid path and that kind of thing. So anyway, I added this, which makes the function a little ugly, but that's what that parameter is for. You could also have if it's a ladder that you bumped into, then you can try climbing up the ladder, that kind of thing. So nav function, we want to make this we could make it take a path and produce a path even. Is path in the brain or here? It's here. Which means we could be... Alright, let's go for it. This is not like commenting things out. You've got to just make the change and deal with it. So we just broke all of the nav code. Let's look at the Pathfinder. So nav function is going to be here, and so I think this class actually becomes a lot simpler. So here we already had the path, we grabbed the position. What did we need the position for? Nothing. So we don't need the position anymore, I think. Man, I've been playing so much of that game Styx that my eyes can't focus on screens, like little screens anymore. I've been playing it on the big TV. I'm like in Act 3 now or something. Oh, what a good game. Spent way too much time playing that damn game. Alright, so don't think we use position again except for here. We're going to replace this one I will comment out. And so we have path, what did I call it? Next. Path next, apply path. And so then we don't need this. this actually changes. It becomes next dot get. I check in on you every stream. At least drop a like and see when you progress into your systems engineering. I've been playing lots of ESO. Oh, Elder Scrolls Online. I will check out Styx. STYX. Styx Blades of Greed. I played the first two. If you like stealthy, sneak around, steal things, and kill people, man, this is like it's a dream. Like you're this little goblin guy. If you can start with the first one, I recommend it. Because by this game you've got like all kinds of powers where you can already turn invisible, and you know, there's like obviously there's an energy level involved. They call it amber, but you can like barf up clones of yourself, and it is yeah, it's crazy. And I just got the ability to like teleport through bars and stuff. It's kind of cool. But it's a cool game. Stealthy, go around. Like I kind of miss in the first and second version. You get kind of bonus experience and stuff if you did a level without killing anybody. So if you figured out how to sneak around and, like, you know, hand over hand on that ledges and like bypass, and you figure out the guard movements and stuff so that you can just sneak through without having to kill anybody, and then you got special bonuses. And so I would redo levels and areas over and over again until I could figure out the patterns to get. And I really enjoyed that puzzle aspect of it. The new version, I feel like they hyped that up in the second version, the sequel, because that one was the one that I really focused on. I did almost the whole game without killing anybody, except for like the couple people you have to kill to progress the story. They don't count those. But the third one, they've done away with that, and so now I try to kill everybody. I mean, like, if you're going to have a goal, I try to eliminate all the bad guys. Sometimes that's tricky too. But now, yeah, I've got so many cool powers. It's like, yeah, I can even like push switches from across the room and stuff. It's kind of cool. And you know, resource balance, because you get materials to craft new darts and things. Anyway, I'm not going to get too far into that. But yeah, I'm totally on. I finished very few games, but I finished the first two Styx, and I probably will finish the third one. I'm on track so far, and I actually care about the story this time. They've like deep into the story a bit. All right, so let's see, path. Get action, but get end. That's the one. Get end. Oh, and this is cool because now I can have actionless paths if I wanted to. Position in, next get end, and get location. So that's all good. We've already got the path. Oh yeah, branch key. So nav grid moves into the nav function. So we don't need to track branch key anymore. We probably don't need a nav grid anymore. I'm thinking this is probably not something I'll get done in this live stream, but we'll see. We'll continue to calculate the heuristic here for now. We'll see. So we will need to get the branch key. Get key. So we will have to change this to be next.get key. So the branch key is how I identify a particular position in the world in a unique way based on the nav grid. You know, we've got cells. You know, we've divided the world up into cells. It always turns my pencil off when I navigate away. You know, so we've divided the world up into cells, and this sort of uniquely identifies a particular cell. And that's how we tell if we've been somewhere already, or if we had like a better path there already, and then we can just skip this path. Okay, so I think that is all Pathfinder needs. And I think that means it doesn't need a nav grid anymore. Let's just see. Yeah, we shouldn't need a nav grid anymore. Oh, maybe to start with. Alright, I'll leave it for now. It doesn't harm anything. But let's search anyway, just to see if there's anything else. Yeah, because I could, instead, for the Pathfinder, instead of taking a start position, I could take the start path, in which case the caller could calculate that for us. But yeah, navgrid is no longer used for anything except for calculating that first initial path, the seed path. Okay. Now, I suspect we broke some things. We certainly broke some tests, which I will worry about later. Yeah, one of the free games this month on PlayStation Plus was Elder Scrolls Online. And so that one's been tempting me. Target condition. Okay, those are all warnings. Navgraph is not abstract. And oh yeah, navgraph. I might have to temporarily break navgraph. I think it's only used in tests. So for now, I will just kill it. Come back and do that later. Some of this is a little tedious for a live stream. Even more tedious than it already is. Hey, I've still got Pepsi left. Alright. So that, all the Java code is happy. We need to make the Groovy code happy. That is going to be interesting. Okay, so we already have navgrid here, which is why it makes sense to put the key in here. So this gets changed to path. Path. Yeah, see, that's all good. Path. Get end, get location. I think. And we're gonna have to make these to the other one. I really wish I'd done this before I made the second nav function, because we're gonna have to do it twice. Okay, so then we're gonna be collecting path results instead. So wherever we're adding to results, add all object actions. I could do this in a different way. Like just in these implementations to simplify things. Yeah, so let's put this let's put this back. So we'll still accumulate the object actions, but instead of just returning results at the end, we're will have a path real result paths. Relay list. So we'll return the paths, and so we'll just each, and so for here, we should be able to say what's the path constructor? Oops. Yeah. This one. So that's got to be public now. Or what we do is we extend path extend into object key return new path this key action. Okay, so that's better. And over here, so we would say paths.add path extend def location equals action.get and too many things to have to look up. So path agent position action get in position see I gotta get it just to get the key and so then where do we calculate the key normally? We don't. That was in Pathfinder before, so we're going to steal that code that I commented out. Oops. Keep clicking the wrong one. Okay, so the old code did this. So we will do similar here. Location. So path extend branch key action. Okay, so that one becomes compatible. That limits the amount we have to do the other one too. We have to change some things. Copy this. Okay. I think that's all I have to change to get basic operations working. Let's see if it works. What I broke, compile errors, etc. Yep, we're down to 2 concurrent viewers. Only the hardcore have stuck around. Well, we're almost done for tonight. Okay, so far so good. All right, let's see if she can make it to the anvil. Work. Nope. No such property pass for physics nav function. Line 1213. Oops. Line 1213. Yeah. Okay, so pass was, where did pass come from before? Oh, pass was passed in. Yeah, that's right. Position pass equals path.get end position, I think is what we need. And we'll need one for the other one too. Alright, we'll try again. Please try again. Branch. Work. Nope. No signature method. Path get in position. Oh. Say what? What's it called then? Get in through. Yeah, I need. This is kids is why consistency is a great thing. Not a foolish consistency, because that's the hobgoblin of little minds, but actual consistency, important consistency, saves you from things like this. Consistent naming in your methods. It's not just anal retentive BS. It will save you time. Okay, let's go to work. Will she work it? Ah, she's working it. Work it, baby. Work it. Okay, follow. Is she gonna get there? Oh, yes. Okay, so that's working. Now, if we stop following her and we come out here and we make a chicken or gafin, gobble gobble. I actually know. I started recording sounds that I was going to use as the gafin sound, and just never did anything with them. Because the creatures in Mythruna don't make sounds yet. What I want? Oh yes, navigate. So if we try to navigate to the anvil, we oh yeah, pending. Pending. We will never make it there. Yep, it's trying, but it's never going to make it. Okay, so cool. We've got the action. We've got the function redefined, which means we can set the heuristic ourselves. We can decide we're going to reject things that are out of bounds. In fact, if we make a wrapper function that removes anything that's too far from the ideal path, we can just compose the... I mean, it's wasteful, but it will work. So the other thing we want to do is we want to let the path function create the heuristic. And so right now in Pathfinder, we call heuristic and we set the heuristic. And I think that we don't want to do this anymore. And what is our default heuristic? Nav function, nav targets is just... yeah, it's just distance. And so if we... I'm going to kill this for now, because we'll need the Pathfinder that doesn't do heuristic calculation anymore. And so then if we go over to here and we add our own heuristic method, protected double heuristic. It's a hard word to type, path. Oh, that's interesting. It is not going to be able to do it. the thing is that alright, so I'm wrong. Heuristic itself still needs to be part of Pathfinder because only the Pathfinder knows where we're going. The nav function does not know where we're going. So this still has to be a part. But we can still potentially override it. Actually, I was about to pull out a piece of gum. What we want is... we want to set... Alright. Yeah, see, we won't know. We won't know at the time of nav function creation what kind of heuristic. So if we assume always a distance heuristic, we like what I'm talking about is when we're navigating to multiple targets, like when we're navigating to all of the chests or all of the chairs or whatever, we would iterate over. So that's the multiple nav targets. So this is when we have multiple nav targets that we're trying to reach. And so to calculate the heuristic, we find the closest one, and we use that as the heuristic, so that as you get closer to a particular chest, those paths get better. So, so only the Pathfinder operation, and specifically only like the thing that's keeping track of your targets and stuff, can know what your raw heuristic, your raw distance heuristic should be. We could just call it distance. And then the paths could have a multiplier that's set by the function. Let me think about that. Because then the nav function itself could set a preset up a weight for the heuristic at the time it creates the path, which means that a full, like for example, a full-grown bipedal humanoid could have a relatively low heuristic for climbing up a ladder, for example. But that's a cost issue, not a heuristic issue. Yeah, I think you'd want heuristic to be constant for a particular so there would be the base factor, your base heuristic multiplier that's part of your path factor, your path function. Yeah, so I feel like it might be, well, it certainly gets me past the problem today while I'm trying to think and talk about it at the same time, would be to build in a private double base heuristic, or heuristic multiplier. And we'll set it to 1 by default. Times heuristic multiplier public void set heuristic multiplier. Let's keep myself out of trouble. Okay. So probably I want to separate this into like an effective heuristic, but for today, the problem is like if some caller was like, I'm going to get the heuristic and I'm going to multiply it myself by something and it would set it back, it wouldn't. I'm a fan of making sure these two reflect the same value, and we're sort of breaking that. All right, so then in setup nav, we can have. Yeah, unfortunately, this means we can't do like squaring. Okay, well, for now, we will use multipliers. But really, this should probably be a heuristic transform that takes a heuristic and returns a heuristic. But today, we will hard code it so as a multiplier. So for regular dumb physics nav function, we will set so path next equals path extend. So for the dumb one, set base heuristic. Yeah, because also it's not really a base heuristic; it's a heuristic scale. So let's just use a big value. Since we were squaring it before, and we'll leave the other one default. And so we'll see what this does if it gets us closer to what I want. I think before I finish tonight, what I want to see is the Mythruna girl navigate to the anvil and the Gafin try to navigate to the anvil in a straight line, fail, and give up. Like run out of paths to check. And so we start the simulation. And we create fade. And we get her to start and then navigate to. Oh, did she actually navigate there? Yeah. Yeah, so she actually made it to there already. So we can go ahead and execute and she'll do the walking. Oh no. Oh my gosh. Why did she walk in such a weird way? That's not good. That's not good at all. Front door. Start. Let's see, how's she doing? Okay, so it seems like she's trying to head a straight line. Yeah, so she somehow picked up the or did I leave something else in somewhere? I did. In the nav dialog itself, we overrode the heuristic function of the Pathfinder. Right? Yeah. But that doesn't mean that the paths are really weird the way it calculates them. We really want it to be kind of a straight line. So maybe I can do something smarter with the heuristic. Anyway, okay, let's see if she can navigate to the front door again. Start, pending. Let's Let's see what she's going to do. Step, 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 step. Yeah, so now she's doing her normal kind of work it around. Yeah, so she'll get to the front door, but she'll try more options to get there. Okay, so she found her way to the front door. We can execute, and she'll get out here, and I'm going to cancel it. So I want to see what she does to get back in. So follow, cancel. Okay. Now let's try and navigate back to the anvil. Clear. Start. Step, 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 step. Yeah, okay. So she's heading in that general direction. That's good. And eventually she'll get there. Yeah. And eventually find a way. Okay, clear. All right. Now let's do the Gafen, which should be using a different heuristic. Create the mob. We'll put it here. And then we will try to navigate to the anvil. Yes, that's good. Oh, anvil. That was fine. Start. Oh. Okay. Path. Set base heuristic. Did I spell it wrong somewhere? Oh, I called it heuristic multiplier. Oh no. So yeah. Oh no. So dumb. I just talked about how it really should be called the heuristic multiplier. That's what I did call it. Good times. Alright, so I'm hoping with just a straight distance multiplier that maybe it doesn't do that weird try to walk straight and then go diagonal thing that it was doing. Alright, so navigate to the anvil. We want to see the pending. Start, step, 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 step. Yeah, okay, this is more like it. So the d squared was, I mean, the distance squared was just too dramatic, and so that was causing it to do like a straight shot here and then a straight shot over. Whereas now we're trying in a general direction towards there. I think if we multiply by an even higher amount, so let's do this. Oops. Let's multiply by 10,000. Let's multiply by 10,000 and try again. And then the next thing we'll do is we'll reject paths that are too far outside. Start, step, 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 step. So if we do this, yeah, so it is expanding, but it was trying to head into a straight line, and it should not go through the door. Yeah, so it doesn't go through the door. Okay, so clear. So the next thing we want to do is calculate the line between. The thing is, we don't know what the destination is. Like, what I wanted to do was, and this may be a case where I need a different interaction than what we've got. So let's say your little thing or whatever, your mob, is trying to get to here, right? As they're trying the various paths and stuff, there's a sort of the ideal path, which is straight there, right? What I wanted to do is kind of take the distance from here for any of these things, and if it's greater than a certain amount, you know, just don't allow that path, just reject it outright. But I don't know where they're trying to go, and in fact they could be trying to go to multiple different places, whichever one they get to first. And the heuristic already knows that. And so the heuristic will be high when they are still far away. But like this heuristic's going to be low. There may not be a good way to do this. Without supplying the heuristic function no single thing has the inputs we need. So the Pathfinder so actually it's not even the Pathfinder that's calculating, it's the thing that knows what the targets are is calculating the heuristic. And what we want to do is we kind of want to pass an additional transform to that, saying and that transform should be based on knowing there's a particular target. So if we've decided we're calculating the heuristic based on this target, then we want to know what that ideal line is. If we decide we're calculating the heuristic based on this target, then we want to know what that ideal line is. And so we want to be able to pass a transform, a temporary transform, but based on the creature. We want to, based on the creature, we want to pass a transform to the heuristic function that is figuring out what the actual raw heuristic is so that we can transform it. And so it's going to need a bunch of parameters, and that's beyond the scope of what I can do here. But what I can do is we see if I clear this and we start step, he will start to expand out here, and like these should be outright rejected. He's heading in the wrong direction, so we could set a threshold. Oh, so here's a trick, right? I don't know which particular target we're reaching, right? I don't know which particular target we're reaching, but I do know the total cost of how long it took to get there so far. So if I'm checking this path, I know what my distance here was, and now I know my distance to here. I'm wondering if I could use those, because in this particular case, well, no, see, I still need to know which one I'm heading towards. Yeah, so I gotta, anyway, so what we can do is kind of, we know in this particular example we're heading towards 1, and I can fudge the numbers. So we know where we are, we know what the cost is. So in the what I'm saying is, in the general case, I can't know whether I'm, like, if we had like done a path to here, and we're checking this particular path, the heuristic calculation is going to figure out that I'm trying to hit here versus here, in which case they would need to calculate how far off I am from this particular path, because if I'm too far either side of this path, I want to reject it, right? Versus if we were heading towards this path, I went too far. So in the general case, it's a complicated problem. In our specific case, we already know we're heading to one target. The thing heading there knows we're heading to one target. And so we could, what was I looking at? So right when we set this up, oh, this is still in the nav function. Well, we know in our dumb physics nav function we're only heading to a single thing at the moment, and so we probably could just set a threshold. Because I don't know what's the inlet, what's the target. I don't know. So yeah, I can't eliminate paths unless their distance function gets particularly high, but I don't even know what a high distance function would be. What I can do, though, is right, no matter what path, where you start and where you end, if if your total cost it took to get there is greater than your heuristic, which is purely distance based at the moment, that must mean that you are outside of the point where any of these would be equal. So there's like a big ellipse, right? Where this distance, yeah, wait, I'm trying to like think what the shape looks like, right? Where your heuristic is greater than your cost, which is purely distance based at this point. And it's not always true, but right now it is. So if your cost is greater than, if your heuristic is greater than your total cost, what does that mean? For the heuristic to be greater than total cost, I think it has to be kind of a shape like this. Right, if we come out here, no, it's kind of like, yeah, so what does the shape look like? If your heuristic is greater than your total cost, so if the heuristic is really small, then your total cost would also have to be really small. So you tend to never reject anything over here. Whereas if your heuristic is really kind of out here, then no, see, heuristic, yeah, no, because then your total cost is going to be still really small. Your heuristic is going to be greater than the total cost. Yeah, so that doesn't really work either. Thought I was onto something there. Yeah, you just don't have enough information to figure it out, to reject these. So my particular, but as an example, I'm going to just pick a total cost that will just reject them. So location, path next, if path, what is it, the cost, path get cost, path get cost is greater than 20, return. And right now I think it's distance and not seconds. I think that, yeah, this is the dumb function. So basically it'll never try very hard. This is not the right answer, but for a Gaphin it's probably the right answer. Like if he tries to pathfind and he gets too far away, he's just not going to do it. So let's see what that does for us. It should change the shape of what we're checking. Start. We want to see the pending. So we should. It'll be interesting to see. Like I could have set it smaller, I suppose. It just takes so long. Once there gets to be a lot of pending, each step, you know, just adds a little bit of thing to it, right? So yeah, so we're starting to reject. I think we're starting to reject paths, but we'll see. Yeah, it got off a little bit. Yeah, see, it is starting to reject paths, I think. We'll see. We should see like these edges start to disappear. Yeah, maybe I set it too high. So the total cost, this is like 1, 2, 3, 4, 5. What did I set? 20? Oh yeah, 20 is way too much. All right, let's try again. And so, navigate. Sorry about that. Let's just do step. Yeah. So, no. See, he's still checking. Okay, so something's wrong. Let me print the path cost. Maybe I have a log already. I do. Okay, so log the path cost. Path.get cost. Maybe I'm wrong about how the cost is calculated. Alright, navigate, start, pending, step. Oh, it's not even using it. But we are using the multiplier. Oh, I put it inside the thing. That's why. I'm an idiot. Live stream brain. All right, let's try again. Navigate, start, pending, step. Okay. So blink. Yeah, so we... Looks like the largest there was a 6. 7. So maybe we should set this to 5. Not 50. 5. Alright. So navigate. I just want to see it reject paths, right? And then we can call it done. Okay, so let's do this. Yeah, so now it's like rejecting anything that's above a certain amount. Yeah. So it did, which is not exactly what we want, because again, we want it to like keep things that are on the path to where it's going. But it did reject some, so it got to a point where it was far enough that it started rejecting the things. It takes it a bit to get there if you're doing single steps, though. Should get just now. Yep, see now it's starting to eliminate these. They're too far away. The cost was too high. Yeah, I still feel like there's some function of... I think you'd have... No, I guess you would have to know what the total possible heuristic is for a given destination before you could do anything useful with the cost and the heuristic. Yeah. Anyway. Alright, I think that's where I'm going to stop it. Thanks for joining. Yeah, so I got like some refactoring to do of, figuring out how to like do a custom heuristic function for a particular mob that modifies whatever the heuristic being calculated is. Turns out to be more complicated than one might think. Anyway, if you guys are working on creative efforts of your own, I hope that you have a productive week. I will continue working on this stuff, and there we go. And like, comment, subscribe. Yeah, it really does help the algorithm. And otherwise, I will see you guys next week, or I'll see you on the Discord server. Thanks a lot. See you next time.